Hi, my name's Todd Mansell, and today we're going to talk about tackling the longitudinal joint. Talk about some best practices to make it uniform. So why do longitudinal joints fail? Mainly because they are lower density than the main line, but why? So there's really 5 things that come to mind when I think about getting low density on there. It's getting a straight line, getting confinement, temperature, segregation, compaction. And all of these things are construction related. I would say 9 out of 10 joints that fail, it's construction. It's probably more than that. It's probably 99% that fail, it's construction related, not materials related. So that's something to keep in mind. Want to get that straight line again on the first and second poles. So first pass, first lane, unsupported edge, get it straight, and then that's going to give us a good guide to get that second pass or that second pole straight. And if it's first one isn't straight, when I come back to match, I'm going to be winging in and out, trying to catch those uneven areas, and I'm going to be have using the manual overrides. That's going to affect my smoothness. Probably going to have to rake the joint, and I'm just going to have a lack of material or a lack of mix at some spots in that areas where that line wasn't straight on the first pass, and I can't get compaction if there's no material there. Confinement. So we'll talk about confinement when it comes to the paver and when it comes to the rollers, building that longitudinal joint. So compaction occurs best in confined spaces. Think about gyratory molds if you're a lab person, right? Proctor molds, Marshall molds, gyratory molds, they're confined, and that mix gets pretty high density when we start using the gyratory super pave or Marshall hammer compacting mix, because it can only go where? In one direction, because it's confined. So what confines it in the field? And we'll talk about that. Temperature. Under the best conditions, the longitudinal joints, the outside edges of our mat, are inherently going to be slightly lower temperatures because of all the mix handling that goes on. It's being handled, if you will, by the augers, comes out of the trucks on the sides or the edges where it's a little cooler. So no matter what we do to remix and put that mat down, we're always going to have slightly lower temperatures along that longitudinal joint or the outside edges of our mat. Segregation is another big one. So I can't get density on a mix if it's segregated. So we do our mix design in the lab, and then we produce it at the plant, and we handle it well. We load trucks and we bring it out to the job, and that mix gets nicely compacted if it's not segregated. But we have more of that handling of the mix to, again, get it out to the longitudinal joints. So we have to do that, get it out to the edges non-segregated. And then compaction. So what do we need for compaction? When it comes to rolling that joint, we need confinement, we need temperature, and non-segregated mix. And we got to think about that roll down factor. So when we're matching lanes, how much do I put down on that second lane? How high is it? Because after I roll it, I want density on it, and I want that to match the first lane that I paved. So we got to think about the rolling pattern. So we're really building 2 edges, if you will, when we make that longitudinal joint. You got the first lane unsupported, no confinement. You've got the second lane supported, that's confined by the first lane, and that's what we call our longitudinal joint. But we have to build both of those edges of each lane, each paver pass, correctly if we're going to get good density on that joint. So let's start with the unsupported edge, or the first lane paved. So again, we want to make sure that we get a straight line. Here you see the picture on the left. The paver operator has a string line nailed down onto the milled surface to give him guidance. His steering guide, that red chain hanging down, is his guide to follow along on that string to get a good straight edge. Could be a paint mark on there. I've seen a contractor use a laser deal, like a laser pointer type thing that shows up in daylight. Bought it off Amazon or somewhere and tied it onto the armrest on the paver seat, pointed it down at the road so that he could use that laser pointer guide to follow the string and keep a straight line. And so there's different ways of doing it, but getting a straight line is really important. So when we look at those things, you can see the video on the bottom right, end gates are down, picture on the left, end gates are down, and the image in the top right, it's just showing us if we get the first pass with a good square edge, now when we come back with the second pass, we've got a good square vertical edge to confine or lock in that second lane and get confinement and be able to get high densities. If I got the end gate up, the image on the left shows what gets thinner and thinner and thinner, so I'm probably going to crush aggregate or break rock when I go to roll that. That's not good for density. Water will get in there and it'll start to ravel. Once it starts raveling, it just accelerates and it'll end up falling apart. But the other thing is that mix that fluffed out on that first pass because my end gates were up in the air, it never gets rolled, right? So it's got 15–20% air voids in it, if not more. So it's uncompacted even after I match that second lane because it's cold. So I take my core and I pray like heck that the average, even though half of that core is 20% air voids, the other half I'm hoping is 99%, and the average still keeps me in spec, but I'm going to have a joint that ends up failing. Temperature under the best conditions, again, inherently going to be a little colder at the outside edges. We just got to think what affects temperature in the field. So it's handling of that mix is really the big thing, right? I mean, we've got lift thickness, we've got ambient air temp, all those things. But as far as the longitudinal joint goes, and what's different about it is that we're inherently dealing with somewhere in the ballpark of typically 10 degrees cooler at the outside edges than that mat's going to be in the middle, just because that mix has been carried out by the augers to the outside edges. So what do we need to do? Hopper management for segregation, and this also affects temperature wise, but hopper management, auger and tunnel extensions, and the mixed feed system. So again, repeating, segregation, I want to get non-segregated mix all the way out to those end gates. So I need augers and tunnel extensions for the width that I'm paving. So the augers aren't boring machines. If they get going too fast, they don't carry that job mix formula nice and uniform all the way to the edges. They start segregating or separating large and stone aggregate and fine aggregates. So we want to run those augers 20 to 40 RPMs, and we need more extensions on front mount than rear mount screeds. Here's your hopper level on the left, looks good, right? Can't see the chains, can't see the tunnel openings, non-segregated. When we get the next truck, dump it on top of that and start paving again. On the right, they've run that hopper down all the way. Let's fold the hopper wings. Now what do we got on the conveyors? We got a big bone pile, coarse aggregate segregation. It's going to come out the back of that screed. And those rocks are the first things that get carried by the augers all the way out to where? To our longitudinal joint. So don't run the hopper low. You can fold the wings if you do it. Well, you have enough mix in there, but don't run that hopper low, and especially don't dump that low hopper like you see on the right there. There's your auger extensions, front mount screed, where the extensions are in front of the main screed. You get away with about 18 inches of between the last auger segment and the end gate. On the right, you see the rear mount screed, so the extension's behind the main screed. The mix kind of flows out into the corners. It's a little more forgiving as far as auger extension because of the way gravity works as we're pulling along forward there. That mix flows back into the corners, so we still need auger extensions, but we can get away with up to about 3 feet between the auger segment and the end gate on a rear mount screed. Mixed feed system, we've got to have head of material. That's the amount of mix in the auger chamber at about half auger height. Want that auger speed at 20 to 40 RPMs so it doesn't segregate the mix. And we've got to aim our feed sensors properly, our sonic feed sensors, so that we control the amount of mix at the outboard end of those augers, and so we don't have those augers coming on and off, on and off. We want them like this, nice and uniform, turning 1/1000, 2/1000. So about 2 seconds per revolution in that 20 to 40 RPM range. Compaction on that unsupported edge. So let's start with compaction. We paved the first lane. We're going to overhang the drum about 6 inches off of that edge. Why? That drum's rigid. The best compactive chance I have, the best density I'm going to get is, because I don't have confinement here, is to overhang that edge. If I get inside that edge, I'm going to push the mix out instead of down. So that's really the main reason for overhanging that unsupported edge. Here we got Patty doing that on the big roller in the subdivision. She's hanging about 6 inches off the edge. That mix is nice and stable. It's not pushing out or shoving out. And that's the best density she's going to get in that situation with that unsupported or unconfined edge. So there you go, another picture. If I hang off that edge, and that's the way I'm going to try it first, and that mix just simply is not stable enough, can't support the weight of that roller that I've got on there. Maybe I use a smaller roller, or I don't have another roller. Mix wants to push out, then I'll move that roller about a foot inside that edge, roll that first, and then come back and roll that 1 foot or 8 inches to 12-inch area that I left near the joint there. But that's the second. That's plan B if I can't do, if the mix isn't stable. I want to definitely avoid being near the edge, within a couple inches or right on the edge. Bad news, because you get high stresses at the edge of that roller drum. It's going to want to either push that mix out, or even if it is stable mix, there's a good chance I'm going to end up with a crack a few inches off of that joint about a year or two later. And a lot of times that's because I rolled a few inches off of that first edge of pavement on the first lane. High stress kind of tears the mix. And again, you might not see it right away. It's going to show up a year or two later. So overhang the edge or stay inside. Avoid doing what you see here, rolling right on that edge. So that's your number one recommendation, overhang. Number two, inside the edge, but not right on the edge. Final prep, what do I need to do? So I've got that unsupported lane paved, end gates were down. I've got it nice vertical edge, it's straight. Now I'm going to tack that edge so that when I come back to match it, it's going to help that second lane or that mix bond to that edge. So I want the tack on there. It's going to help it be less permeable to water. Some jobs were cutting or trimming that edge. I still don't think that it's necessary if we build that first lane properly with the end gate down and overhang it with the roller and get the best density we can on that edge. I think I've seen it in my experience. We can get good joint densities without necessarily having to trim or cut back that joint. But some job specs call for that. Most airports I've been on, they call for trimming or cutting back that edge. And there you see a roller with a pizza cutter on it. That's one way of doing it. You could do it with a saw cut it. That's a lot more labor intensive and expensive. But the roller, you got to drive it straight. You got to do it while the mix has still got some heat in it. So that pizza cutter wheel on the roller is going along, taking off that, I'll call it loose fluff on there. And we're definitely going to have to do this if we run that first pass with the end gate up and still want to get good joint density. So cutting that loose fluff off, and then you're coming back with a grater or something to pick up that loose material that we just trimmed off and get rid of it. If I've got narrower lanes than my main line, there's an attachment called a cutoff shoe that we can put on the paver in the screed of the paver. And what that does is allows us to pave narrower than the width of that main screed. So the guys on the left there, they're on a county road. I think it's 10 feet wide, that lane. They can only pave 9 feet by the looks of it there. Looks like about 9. They've got a cutoff shoe, so they still got a good vertical edge on that joint. Guys on the right did a terrible job. They went in, what they do? They just used the manual override feeds, fed mix back to one half of the paver. But and when you do that, you're going to get that uneven line that you see in that picture on the right. And then they got to come back with a skid steer or grater, trim that all off while the mix is getting cold, and it just looks terrible. And they're going to have low joint density. I got the excuse on that job that it's only base. Well, it still matters. So we got the first lane paved and compacted. Now second lane, the unsupported edge, or the supported edge. We got a straight line. We want to get a straight line still. If we got the straight line on the first pass, the second one should just be follow that first lane. End gates down, manage segregation. We can't get compaction on segregated mixes. And then we want to get the right height match again, right? So big thing there is our roll down. And we can eliminate raking on that joint if we get the right height match. So what's my roll down factor? I get about 1/4 of an inch per inch compaction or roll down. So if I put 2.5 inches loose, it's going to roll down 1/2 an inch. So 1/4 inch for every inch of lift thickness. I end up 2.5 loose. It's going to end up about 2 inches after compaction. And if I'm using automatic grade control, the position lined up with the auger is going to give me a perfect joint match with the adjacent lane. So here you see a picture, and the right you see the video. They're doing a perfect joint match. I've already got the first lane paved the way they want it. Now I got the roll down factored in there. Roller's going to come in and compact that. I'm going to have a nice, well compacted joint. I can use the ski for joint matching. So if I've already got a good base or intermediate lift down, I can come back now and match it with the ski, and it's the same deal. I don't need to rake it if I've got the right height in there, height match. And here I'm going to get really good smoothness as well. Joint overlap with that paver. So now I'm matching that lane, creating my longitudinal joint. I don't need a lot of joint overlap. I need just enough to be able to get the mix up good and tight against that joint, and high enough so that when I roll it down, I've got good height match. So the first lane, again, must be straight on the first hole. I don't want to rake the joint. These guys rake the heck out of this joint here. Look at all that material broadcast all over the place. It's almost to the point of being badly segregated. But when you push that rake or that lute off the existing pavement, and even if you don't broadcast that mix, you're pushing mix or material away from that joint. So if it's not there, you can't get density on it. And it looks like heck, right? Just does not look good at all when we're done. If we've got large stone mixes, 3/4 or even 1 inch rock, you may have to, what we call, bump the joint with the lute just to get some of those big rocks, that big material over top, so that when the roller hits it, it'll roll down and not crush or break rock on the existing lane. But sometimes just a nice light bump like you see here in that picture. No raking, showing a video here. Guys on the left, no raking there on that joint. Even on the right side, this is a P401 1 inch base mix on an airport job. No raking, right? Just because they got the right amount of overlap and the right height match. So again, it's a team effort. Getting good joint density is not just the job or the responsibility of the roller operators. It's the paver and the rollers working together. So rolling the final joint, I look at production versus density. I mean, we got to get production, we got to get quality, we got to get density. So what I do, I like to try what I call the high production method first. And if density is really the goal, or I'm not getting density, then I'm going to try plan B. And I'm going to show you both here. So right now, Dave here, he's on the roller. The first pass on the hot lane, he's overlapped 6 inches onto the cold, and it's confined. He's vibrating, he's compacting, pushing that mix up against the joint, getting pretty good joint densities. But these guys weren't in a big hurry on this job. It wasn't that long of a section, a 1/4 mile or so. So what they were really focused on was wanting to get the highest joint density possible. So we did that little section, and then what we did was rolled it again, only this time we left about 1 foot, actually a little more than 1 foot, all the way, rollers all the way on the hot mat. Got, like I said, about 1 foot, maybe a little more than that, uncompacted. But that uncompacted mix now is what? Locked in. It's confined. It's confined by the pass Dave just made there, and it's confined by the cold lane that he's going to roll off onto. Now he's coming back, and we've got that 14, 16 inches of mix wide strip. He's going to compact it. It's locked in on both sides now. His first roller pass and that cold lane, locking it in. That mix has nowhere to go but down. And the densities on this job, when we used that rolling pattern, we couldn't tell just by looking at the core data whether those cores were on the joint or in the middle of the main line. They were really good high densities because it was locked in, and Dave talked to the screed operator because he was a little bit high initially, brought that mix down, or that screed down just a tiny bit, a few millimeters, eighth of an inch, so that after Dave rolled it, we had good joint densities. And the final thought here maybe is a hot joint. So echelon paving. Here you see two pavers paving side by side. Effectively, there is no joint, right? So it's a hot joint. The pavers don't necessarily have to be right close like these two are. The reason these guys were so close was so they could use one shuttle buggy, one transfer machine to feed both pavers. But that just eliminates that cold joint. So 5 things to keep in mind: make it straight, confinement, temperature, segregation, compact it quickly, and the skill. And I love this quote. Came out of one of the publications referenced at the bottom there. But the skill and experience of the screed operator, raker, and roller operator are probably the most vital component in making a good longitudinal joint. I agree 100%. Right? It's construction related, construction quality, but it is everybody's job. Paver operator, roller operators, screed, loot, ground crew, the whole bit. So kind of a checklist: unsupported, first lane pave, make it straight, auger and tunnel extensions, end gates down, first roller pass, overhang the edge about 6 inches off that unsupported edge. And if the mix is unstable, then maybe go in about a foot and then come back. On the supported edge, the second lane we pave, same thing. End gates are going to be down again. Grade control, if we've got it, set that sensor so we get a good joint match. You could be using the ski on a smoothness job on to joint match. Make that first roller pass all the way onto the hot, overlapping a bit onto the cold. If I want the highest joint density I can get, stay off of that joint about a foot, and then come back and roll that 1 foot strip because now it's locked in on both sides. So these are just the highlights. Thank you very much for your attention looking at longitudinal joint construction. Thank you.